Have you ever seen a situation where adding a small feature breaks your existing code? Today, I'll show you why that happens and how dependency inversion principle fixes it using a simple C# example. Let's take a real-time example of e-commerce. For that, first we will make a card payment class. Here, we have a card payment class that does the payment. And we have an order processor class. Order processor is directly depending on card payment. That means these two classes are tightly coupled. Here, this line is a problem. Card payment is equal to new card payment. Now, in our main program, I will call the order processor in main class. The main issue is that if in future I need to add UPI payment or other payment options, then we must come back and modify order processor again and again. For example, if I add a UPI payment class, and order processor depend here on UPI payment. Inside order processor class, I'm using if else. And if in future I need to add multiple payments options, I need to extend this else if statement. Here, the problem is it is not flexible and hard to test. In future, there can be too many changes. Here, a high level class depending on low class level, which is a bad design. So, to fix this, we use dependency inversion principle. In this, we will use dependency injection also. So instead of depending on card payment, order processor will depend on an interface. First, we create an interface, iPayment. Now, order processor doesn't care about card or UPI. It only knows that someone will pay. Now we implement this interface card payment inherited by iPayment. Inside order processor class, we will inject the payment object from outside using dependency injection. This is called constructor injection. Here, order processor doesn't care which payment method is used. Now, let's see how we call this in main program. Here, if client wants card, I pass card payment. If client wants UPI, I just change one line. No change in order processor code. Earlier, modification required changing business logic, but in using dependency inversion, we can add UPI payment inside the interface. Now modification happens only at object creation time. There will be no if else. Both card payment and UPI payment follow the same contract I payment. Dependency inversion principle means high level module should depend on abstraction, not implementation.